Hey everybody, welcome back. This is the third video in our VLAN series. If you watched videos 1 and 2, you'll already know where we are with this, but if you have not watched video 1 and 2, I'll just kind of give you a brief summary, or you can go back and watch those videos. But in video 1, we configured our network here in building 1, and we just described what VLANs were, why you would need them, and we placed the ports that PC1 and PC2 are connected to into VLAN 10, which is the accounting VLAN, and the ports that PC3 and PC4 are connected to, we placed in VLAN 20, which is our marketing VLAN. In video 2, we expanded our network into another building. We put in another switch. We created VLAN 10 and 20 on this switch as well, and we placed PC5 into VLAN 10, PC6 into VLAN 20, and then we created our link between the switches and made those ports trunk ports, and we explained what trunking is and why you would want trunking. And what we had decided we would do with video 3 is show you a scenario called router on a stick. And what that is this. Let's say that we created these separate VLANs to cut down on the number of broadcasts. So the broadcasts from the PCs in VLAN 10 aren't seen on the PCs in VLAN 20 and vice versa. And let's assume we've got a server over in VLAN 20. But even though we've separated these VLANs to cut down on the number of broadcasts, perhaps the computers in VLAN 10 need to be able to access this server that is in VLAN 20. And how are they going to do that? Because now we've got these VLANs and they cannot communicate with each other. Well, the way we do that is with routing. There are two ways we can do that. We can have the switch do it if it's a layer 3 switch, but in our case we don't have a layer 3 switch. So what we're going to do is show you something called router on a stick. So once you see what this looks like, it'll be obvious why they call it router on a stick. We'll use our fast Ethernet 00 port to connect it to the switch, and we'll use fast Ethernet port 0/24. And there's why it's called a router on a stick. It looks like the router on the end of a stick. But basically the theory behind this is when the PCs in VLAN 10 try to access VLAN 20, they are going to use this router as the default gateway. And this router, the interface here, is going to be configured for both VLANs. And so that's how it's going to route traffic over to VLAN 20. Now to do this, we're going to use something called sub-interfaces. So as you remember, we plugged this cable into fast Ethernet port 0/0. Well, with sub-interfaces, you can take that one physical interface and split it into separate sub-interfaces, kind of like virtual interfaces. And that way it's almost like you've plugged two ports of a router into two separate ports on a switch, but here we're just using one port on the switch and one port on the router to accomplish what we need. So let's go ahead and go into the router and just it's a brand new router, so let's go in. Sorry. go into Fast Ethernet 00. Now on a router, of course, our interfaces are shut down by default, whereas on a switch they're up by default. So the first thing we're going to want to do is on Fast Ethernet 00, the physical interface, we're just going to issue the no shutdown command to bring that port up. And now we're going to create our sub interfaces. So the way you do that is put Internet Fast Ethernet 0/0 and follow that by dot and then the number you want to give to the sub interface. So in this case we're going to make sub interface 10 for VLAN 10. So now we've created that sub interface. Let's go back to let's do an IP or show IP internet interface brief and look at our interfaces. So we already had physical interface Fast Ethernet 00 and 01, but you can see we've got this sub interface created. So we don't have any additional physical ports, but we've got this virtual or port, or basically it's a sub interface underneath 00. So now let's go in, and we're also going to create sub interface 20 under that physical interface, and we'll do that for VLAN 20. So now we've got our two sub interfaces. I'm going to go back to the interface that we're going to use for VLAN 10, and the first thing you want to do is enter the command encapsulation .1q, and then you tell it which VLAN you want that sub interface to be on. So we want it on VLAN 10. And now we can give it an IP address in VLAN 10. So our subnet for VLAN 10 is the 192.168.10 network, and we're just going to make it .1 and then give it a subnet mask, and that's all there is to it. So now let's go to our other sub interface and do the same thing. So we're going to tell it we want it to be in VLAN 20, and we're going to give it an IP address in VLAN 20. Now these two interfaces are the IP addresses we will give to our PCs as their default gateway. So at this point, that's all we need to do on the router. So we've created our sub interfaces, given them IP addresses in their respective VLANs, and now we'll go to our switch, because what we have to do on the switch is enable trunking. Now remember, we talked about trunks being links between switches, but in this case we need a trunk link to the router because that interface is also going to carry traffic across multiple VLANs. So let's go into port 24, which is where we've connected our router, and we are going to set our switch port mode to trunk. And that's really all we need to do at this point. So let's go back to our router, and we're going to ping something in VLAN 10. Oh, wait. We have to wait till this turns green before it's going to work. Alright, let's try again. There we go. And now we'll try to ping something in VLAN 20. that works as well. Now, of course, you would expect that because the router is, as far as the router is concerned, it's physically plugged into both of those networks, so it knows where both of those networks are. But let's go to our PC here, and first thing we'll try to do, we'll see if we can ping the router. It'd help if I put it in the right subnet. And now let's see what happens if we try to ping something in another subnet. That's not going to work. I'll explain why in just a minute, but let's go ahead and try to ping PC3. And it doesn't work, and that's simply because we have not given our PCs a default gateway, so they don't know the route to, they have no idea how to get to VLAN 20 or subnet 20 without going to a router. So our default gateway is going to be 10.1, and you have to bear with me, we'll have to do this for each PC. .1 is our sub interface in VLAN 1 on the router. And for sub interface 20 that's in VLAN 20, we made that IP address 20.1. Alright, so now what should happen, let's go back to PC1. When I try to ping something in VLAN 20, it's going to look at the IP address, it's going to figure out that, you know, this is not in my network, this is not on the 10 network, it's on another network that I don't know about, so I'm going to send that to my default gateway, which is the router here, and the router knows where subnet 20 is, and it's going to send it back out the same interface, same physical interface, but a separate sub interface, and send that out to VLAN 20. So let's try to ping again, and now we're getting replies. So that's basically all there is to know about router on a stick. And if you keep checking back, because in a future video we'll probably talk about how you would do this if this switch here were a layer 3 switch. Matter of fact, we'll go ahead and look forward to video 4 in this series, and that's what we'll talk about in video 4, is if we had a layer 3 switch, and show you how you could do this without having the router in the picture. Thanks a lot.